Now to solve this, we have to look for the hypotenuse. Okay? And so we're going to be using the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the two legs of the triangle, and c is the hypotenuse. Okay? And a lot of times when we're combining vectors, whether they're parallel or perpendicular, we talk about the resultant. That's the answer, that's what you're going to get. So in this case, the hypotenuse is my resultant. It's what I'm looking for. Okay, so I'm going to plug in my numbers. I'm going to get 6 squared plus 8 squared equals c squared. And it doesn't matter if 6 is a or 6 is b, it's both the legs, so it'll work out the same way. Okay, now 6 squared is 36, okay, plus 8 squared is 64 equals c squared. Okay, so now I'm going to add those two together. I get 100 equals c squared. Okay, and then when I'm trying to get rid of this squared, find the square root of both sides, and I get that c equals 10. Okay, so I have found that when I combine these two vectors, I get a magnitude of 10. And a lot of people, they're going to stop right here because they think I found the answer, I know what I'm doing. But the important thing is anytime you're finding a vector, you're finding both magnitude and direction. So I have just found the magnitude of my vector, but I have to figure out the direction. And the direction is going to be from this angle. We often use theta to represent our angles. Okay, so I'm going to erase a little bit of this so that we know. We have the magnitude of our answer. Now we need to find this angle. Now to do that, I'm going to use your geometry functions of sine, cosine, and tangent. Okay? If I'm going to plug this in, I have my angle, and I'll tell you what I recommend. I always recommend using the numbers that were given to you. Okay? Because if you made a mistake on this number, you plug them in, it might still come out wrong. But I recommend to use the ones you were given. Okay, so you were given these two sides. So this is your opposite side and this is your adjacent side. So if I was going to use my sine function that was opposite over adjacent, if I was going to use my function that was opposite over adjacent, it would be tangent. Okay, so we do tangent of this angle equals opposite, which is 8, over adjacent, which is 6. Now,
how do you solve that, Mr. Childers?
Mr. May is going to show you how to plug that into the calculator.
Inverse tangent of 8 over 6. And it looks like 53.1 degrees.
So theta that I found was 53.1 degrees. And just to show you what he did, okay, we were trying to get theta all by yourself, so you had to put tangent over to the other side. Okay, on your calculator, the button that you use for that is the inverse tangent, or you see that tangent looks like tangent to the -1, okay, of 8 over 6. He plugged that into the calculator, and this was the answer we got. Okay, so this, now it tells me that I am 53.1 degrees from this vector, and I have a magnitude of 10 newtons. Okay, so I have both a magnitude and a direction. Now the important thing to see is that if, at the very beginning of this problem, if I would have set up this triangle differently, if I would have decided, hey, I'm going to put in my 8 Newton vector first, okay, and since we said it has to be set up tip to tail, here's the tip of my arrow, there's the tail of my other one, we set it up this way, I would still get the same triangle, okay, it would look different, but I have an 8 Newton and a 6 Newton, I'd work it out with a Pythagorean theorem, and I would still get a 10 Newton resultant. Okay, but if I worked out this angle, I would not get 53. Okay, I would get, if I'm looking at it, okay, theta in this case would be 36.9.
Let's see what Mr. Calculator says. 36.9.
Okay, and that's because I'm telling you that direction from a different angle. Now I'm telling you it's 36.9 degrees from this vector. Okay, they're still both correct, they still both work out the same way, okay, but it's a different way to look at it. We still get the same magnitude and it's telling you the direction from a different point.